Now, one other thing to note here is that this x by d is what? If this angle is theta, remember that this distance is very large. So since this distance is very large, what we can assume is that this distance is very large. We can assume that s1 and s2 and this angle is theta. Now since this distance is very large, we can assume that this wave and this wave are parallel. This line and this line are parallel because this distance is very large. Obviously theta 1, maybe this theta 1 and this theta 2 are exactly not equal to theta, and theta 1 is not equal to theta 2, but since this distance is very large, so actually the difference between theta 1 and theta is very less. So I can approximate this as theta, this also I can approximate as theta. So that means I can say that s1, this line, the wave coming from s1 and the wave going from s2 are approximately parallel. So if they are parallel and this angle is theta, this angle is theta, that means what? That means this angle is also theta, right? Got it? The reason is that this angle is theta, so this angle is also theta. This angle is 90 minus theta, so this angle is also theta. And this distance is you know as d. So what is this distance? This distance you can write as d sine theta, right? So the path difference is also equal to d sine theta. The path difference is actually this distance is the path difference between the two waves, so this is equal to d sine theta. Okay. Now you know that if we have a constructive interference, then what should be the case? In that case, the path difference should be equal to k lambda, and when we have destructive interference, you know that the path difference should be equal to k plus half lambda. So what are the positions of x where we have constructive interference? We can get that as k lambda d by d. And what are the positions where we have destructive interference? We can get as k plus half lambda d by d. Okay, so now let's put the values of k and see where we are getting constructive and destructive interferences. So we saw that for constructive interference, x is equal to k lambda d by d, and for destructive interference, x is equal to k plus half lambda d by d. Now this is my screen. If I put k equal to 0, I get a constructive interference, x is equal to 0. So that means here I get a central bright fringe. Now if I put k equals to 1, I get the second one as lambda d by d. Here again I get a bright fringe, or the first bright fringe. Again if I put 2, I get at 2 lambda d by d. Similarly this side at minus d by d and at minus 2 lambda d by d. I get the, here is the first one, this here is the second one on the negative side. Now for destructive interference, if I put k equals to 0, I get it at lambda d by 2d, again at minus lambda d by 2d. If I put k equals to 1, I get at 3 lambda d by 2d, and here I get at minus 3 lambda d by 2d. So you can see here that between any two bright fringes, I have a dark fringe. So here you see that this was the bright fringe, this was the bright fringe, here I have a dark fringe. Similarly, this was the bright fringe, this was the bright fringe, and this we have the dark fringe. Now what is the fringe width? Fringe width we define as the width of the fringe. So I can get the fringe width as, let's say, xn plus 1 minus xn. The width of this dark fringe will be the difference between the positions of this two bright fringes. So that's why I get this formula. So if I put here, I'll get the fringe width as k plus 1 lambda d by d minus k lambda d by d, or lambda d by d. So this is the width of the fringe. Now we have a width of the fringe. We have something called as the angular fringe width. How we define angular fringe width is that, let's say I have a dark fringe here. So what is the angle subtended by this dark fringe? Here it will subtend some angle, so we have to find this angle. This is known as the angular fringe width. Now this we can find by dividing this distance, this width divided by this length, that is d, because tan theta is equal to, you know, this by this. So this is the width by this, and since this theta is very small, I can approximate this also as theta, or let's call this as beta. Let's call this angle as beta. So tan beta is also equal to beta, and if I write this as this, I'll get the fringe, angular fringe width, that's lambda by d. So this is the angular fringe width. Okay.